Good evening. Good evening, ladies and gentlemen. My name is Doug Hube. As honorary president of the Edmonton Centre of the Royal Astronomical Society of Canada, I have the pleasure of welcoming you to this very special evening with a very special speaker. Before I say any more, let me point out that this program is being webcast, and all they will see is the backs of your heads, so I'm sure you're reasonably comfortable with that. Could I also ask that if anybody has a cell phone or any other electronic device that may make some noise, that you turn it off now. Thank you. Your host this evening is the Edmonton Centre of the Royal Astronomical Society of Canada. The RASC is the oldest scientific organization in Canada. Most of its members are amateur astronomers. Our sister organization, the Canadian Astronomical Society, is the society to which professional astronomers belong. Those two organizations jointly sponsor two lectures each year, the Hogg Lecture, which you are attending this evening, and the Northcott Lecture. Helen Sawyer Hogg, after whom this lecture is named, was an American-born astronomer who spent most of her career at the University of Toronto. She was a world-renowned expert in the study of variable stars and globular clusters, work which was fundamental to determining distances in the universe and to understanding the evolution of stars. For many years, she wrote a regular column for the Toronto Star. A collection of those columns was subsequently published in a book entitled The Stars Belong to Everyone, a book that has inspired many people to learn about the astronomical universe. Helen Hogg was widely respected as scientist and educator and well loved for her kindness and humility. She had a connection with Edmonton. It was Helen Hogg who formally opened on July 1st, 1984, what was then called the Edmonton Space Sciences Center, now the TELUS World of Science. And therefore it's entirely appropriate that a public lecture be given in Edmonton in Helen Hogg's memory. It is now my pleasure to call on the National President of the Royal Astronomical Society of Canada, Mary Lou Whitehorn, to introduce this evening's illustrious speaker.
I cannot tell you how thrilled I am. Honored, pleased, and thrilled to introduce our Helen Sawyer Hogg Memorial Lecture 2012, Dame Jocelyn Burnell. She started her academic career by failing the Northern Ireland equivalent at around grade 6. Very auspicious beginnings. But from that, she went on to read a physics degree at Glasgow University in Scotland, and followed that with a PhD in Cambridge in radio astronomy. And this is where she made that legendary discovery of pulsars, opening up a whole new branch of astrophysics and making astronomy classes interesting for everyone ever since. This work was recognized, of course, by the Nobel Prize being awarded to her supervisor, but not to her. She married a man that she refers to as her peripatetic husband, which meant that she worked at the University of Southampton in gamma-ray astronomy, at the University of College London in X-ray astronomy, then back to Scotland to work in infrared astronomy at the Royal Observatory in Edinburgh, and this was followed by a management position at James Clerk Maxwell Telescope in Hawaii. And for most of this, she worked part-time while she was raising a family. So she's setting a tremendous example that you can have it all. She has chaired and served and serviced more research council boards, committees, and panels than she wants to remember, and has chaired a European Community Committee. She has been president of the Royal Astronomical Society, the original Royal Astronomical Society across the pond. And in 2008, became the first female president of the Institute of Physics. That's only 4 years ago. She has used telescopes on high-altitude balloons, launched on rockets and carried on satellites, has built a radio telescope firmly planted here on Earth, and has panted for breath at 14,000 feet on the summit of Mauna Kea using the United Kingdom's infrared telescope. After 3 years as Dean of Science at the University of Bath, she retired in 2004, moved to a visiting professorship at the University of Oxford and a professorial fellowship at Mansfield College, also in Oxford. For 10 years, she was professor of physics at the Open University and spent a year as a distinguished visiting professor at Princeton University in the United States. And I'm tired just reading this. Dr. Burnell has been honored many times with major awards: the Oppenheimer Prize, the Michelson Medal, the Tinsley Prize, the Magellanic Premium, the Herschel Medal, multiple honorary doctorates, several honorary fellowships, the list goes on. She was made a commander of the British Empire in 1999 and also won the Edinburgh Medal for Services to Science and Society in the same year. She became a Fellow of the Royal Society in 2003. She's got to have a tremendous trophy shelf. And a Fellow of the Royal Society of Edinburgh in 2004, and has been elected a Foreign Associate to the United States National Academy of Sciences in 2005. And following this, in 2007, was made a Dame of the British Empire. So she's been knighted. Amazing accomplishments by one woman scientist. The public appreciation and understanding of science have always been important to her. She is much in demand as a speaker and a broadcaster. The Royal Society awarded her its 2010 Faraday Medal for Science Communication. Her appointment to the Open University doubled the number of female professors of physics in the UK. And she hopes that her presence as a senior woman in science will encourage more women to consider a career in science. In her spare time, an interesting concept, she walks gardens, listens to choral music, and is active in the Religious Society of Friends, or the Quakers, and has co-edited an anthology of poetry with an astronomical theme, Dark Matter, Poems of Space. So I am deeply honored and utterly delighted to introduce an incredible role model and an amazing scientist and a remarkable person, Dame Jocelyn Burnell. Please join me in a warm and enthusiastic welcome for our guest of honor tonight.
Thank you very much. Thank you, Mary. Thank you very much. Thank you for that very generous introduction. And thank you for the privilege, the honor, the opportunity of being here to give this lecture. I've been in Edmonton before, but not for a good many years. I don't remember it having such fantastic weather. And I'm immensely grateful to all of you on a wonderful Saturday evening of a holiday weekend for taking the trouble to come here this evening. So thank you very much for your interest. I don't know how much this is an issue in Canada, but certainly a little bit further south on this continent, there's a lot of concern that the end of the world is imminent. It all seems to stem from the Mayan calendar. The Mayan calendar, like our calendar, had many cycles. We have weeks, months, years, centuries. They had cycles as well. The one cycle that's rather longer than any of ours, which we, I think, not they, call the long count. And one of the Mayan long counts began in August 3114 BCE, and the end of that count, that cycle, occurs on the 21st of December this year. I don't think it's part of Mayan cosmology, but other people have taken this end of a cycle and said, woo, end of the world. I think the Mayans had much the same attitude as we had. You know, important landmark, let's have a party, maybe a day off work, then turn over the page and back to work. New cycle, new start, but definitely not the end of anything. The prediction that it's going to be the end of the world, of course, some kind of method for ending the world is needed. And there are plenty of those. There's people saying, oh, it's going to be a massive earthquake, a hurricane, tsunami, what have you. Or there's a whole collection of things that are going to happen caused by causes from asteroids. And because I've got an astronomical background, I'm going to look at the astronomical suggestions, postulates, the things that might cause the end of the world in 2012. But it's as well to keep our feet firmly on the ground. Their calendars were engraved on stone, and stones are finite size. Sooner or later, they run out of space on the stone. But actually, I think the Mayans knew what they were doing. They were surprisingly good mathematicians. They worked to the base 20, from which you deduce they had bare feet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they knew all about the movements of the planets, they knew about the movement of the sun, and they will have known that on the 21st of December or thereabouts, the sun is as far south as it gets each year. So I think the choice of date is probably deliberate. So 21st of December 2012. Some people are prepared to be very, very precise, either at 11:11 a.m. or maybe 11:11 p.m. UT. But UT, Universal Time, is much the same as Greenwich Mean Time, GMT, so there's a 12-hour ambiguity. And coming from Europe, I thought all these 11s, it's resonating with the signing of the armistice at the end of the World War at 11 a.m. on the 11th of the 11th month. But actually, I think it's the solstice, and they're a minute out, because at 11:12 a.m. on the 21st of December this year, the sun is as far south as it gets this year. So maybe at 11:12 rather than 11:11. So is this true? Will it happen? And how will it happen? Let's look at some of the things that have been suggested as causing the end of the world. And I've grouped them. There's a group of things around the Earth, in particular concerned with the Earth's magnetic field, the thing that makes your compass needle point north. Whoa, the Earth's magnetic field is going to reverse, and the Earth will stop spinning, and then start spinning the other way. And clearly that will be the end of the world. So that's something we can look at. There's also a group of things around the sun. Two things here. Sun's magnetic field reverses from time to time. Whoa, sun's magnetic field is going to reverse on the 21st of December. And that's clearly the end of the world. And if that doesn't work, well, there's going to be a major solar storm, and that's going to take the whole Earth out. So we'll start with the sun. Two images of the sun here. They're slightly different colors because they're taken with slightly different cameras. Apologies for that. The thing to observe is that the right-hand image of the sun is blank, and the left-hand one has some dark marks on it. These are sunspots. They're actually areas that are a little bit cooler than the rest of the surface of the sun, so they don't shine quite so brightly, so they look dark by contrast. They are actually still jolly hot. And they're very big. If you were to wheel the Earth up, say, to that sunspot, you'd find that it was comparable in size to the whole Earth. But you don't want to wheel the Earth up there because the temperature is 6,500 degrees Celsius. So, sun sometimes has no spots, sun sometimes has spots. It goes in 11-year cycles, and the sun's magnetic field also goes in 11-year cycles, or more precisely 22-year cycles. So sun's magnetic field starts like that. After 11 years or so it does that. After another 11 it does that, making 22 years for the full cycle. sunspots come and go on an 11-year cycle. The sun's magnetic field last reversed in 2010, just a couple of years ago. And if it's going to do it in 11 years' time or so, 9, 10, 11, 12 years' time, it's not going to do it in 2012. There's no reversal of the sun's magnetic field in 2012. I don't want to cast aspersions on how old any of you are, but anybody over the age of about 12 or 13 already experienced one, if not two, of these reversals, and some of you clearly have experienced quite a few. You remember them well, the major trauma, don't you, every 11 years. Since there's been tool-using people on Earth the last 2.5 million years, the magnetic field has reversed something like 250,000 times. And it doesn't seem to have affected our evolution. So even if there were a magnetic field, sun's magnetic field reversal later this year, I don't think it would have any effect, and we don't believe there will be one anyway. Discount, I think, the solar magnetic field. Solar storms. Solar storms are jets, blasts of charged particles coming out from the sun, out into space, and sometimes the Earth's in the way of one of these jets and it gets a solar storm. Sometimes a spacecraft is in the way of one of these jets and it gets a solar storm. Solar storms go roughly along with the number of sunspots. So at the time when this left-hand photograph was taken, you might expect quite a few solar storms. At the time when the right-hand photograph was taken, you wouldn't expect many. I've got a very long, thin graph here, which I had to split into two. Starts about 1750, runs to 1800, starts again in the year 1800, runs to 2010. And what's plotted is the number of sunspots. And you can see that it goes up and down, up and down, up and down, and that these bumps come roughly every 11 years. What's very variable is how high the bumps are, how many sunspots there are in that particular cycle. It varies quite a lot. In recent years we've had relatively high ones, then there was a spell of lower ones, medium, some very low ones, and so on. Now, something funny happened with the sun around about here. The sunspot numbers dropped away and dropped away and dropped away, and we said, yep, right, okay, end of one solar cycle. And then nothing happened. No new sunspots came. And no new sunspots came, and no new sunspots came. We thought, what the hell is going on in the sun? And then finally it got round to having some sunspots and some solar storms, and the number is now growing. We're not quite sure what is happening with the sun. There's all sorts of curious pieces of evidence suggesting things have been changing, maybe going as far back as about here, not just in the last tail of the last cycle. So we don't really know quite what's happening, but it's meant that predictions about what the height of the next bump will be have had to be revised, have had to be pushed later and made smaller as the sun refused to start any new sunspot cycle. And as of February this year, the prediction is that the next bump will be this high, and it'll be delayed, it'll come late in 2013. If the sun had behaved more normally, the peak might have been in 2012. And some of you may have noticed adverts from travel agents. This is the year to see the Northern Lights. Go take an expensive trip to the Arctic. I'm afraid the travel agents don't know about this. 2013 is the year when there'll probably be more Northern Lights, but they may not be that fantastic because this peak's not going to be very high, and you maybe just stay in Canada and see the Northern Lights from home, rather than take an expensive trip. So the next solar cycle is expected to be rather feeble and rather delayed. And as a consequence, we don't expect so many solar storms. Now, this is a bit like predicting the weather. It's an art as much as a science. And you can't be absolutely certain. There could be a one-dinger of a solar storm in spite of the small numbers of sunspots expected. But it's likely that there won't be major solar storms. So, temperature on that one. To date, solar storms have not caused immense damage on Earth. There was a famous occasion a while back where a solar storm sent, I believe, a reverse current around some of the Ottawa power supply, and the reverse current burnt out one or two things because reverse currents weren't expected, and a number of homes in Quebec area were out of power for quite some time. To the best of my knowledge, that's the only damage that a solar storm has ever done. And part of that was human stupidity in the way we wired up those power circuits, from which we have learned, I hasten to say. And solar storms to date have never killed anybody. So it's a little hard to see how a solar storm could cause the end of the world. So I don't think that one's going to fly either. Which brings me on to the Earth, where we started. This idea that the Earth's magnetic field is going to reverse, the Earth is going to stop spinning and start spinning the other way. The Earth's magnetic field does reverse. Geologists talk about it flipping. So the Earth's magnetic field flips over, and what was north becomes south, and vice versa. It flips irregularly. It doesn't do it predictably the way the sun does. And this bar chart on the right is 3 million years worth of history. 1 million years ago, 2 million years ago, 3 million years ago. And where there's black shading, it has the magnetic field pointing the same way as at the moment. White is opposite, same, opposite, same, opposite, same, opposite, same, opposite, same, and so on. And you can see it goes backwards and forwards, but it's not periodic, it's not rhythmic, it's irregular. Reversals happen typically every 300,000 years, but we've had quite a long spell, much longer than that, with the present configuration. And so some people say, oh, we're overdue a reversal of the Earth's magnetic field. Tool-using man came along somewhere about here, and these reversals don't seem to have affected the evolution of humankind. There's no obvious evidence for mass extinctions at the times of any of these reversals. There are some research groups that believe they can see extinctions of some very, very small organisms, but I think the jury is still out on that. But in terms of 21st of December this year, the real cruncher is what the geologists call a flip. It takes 5,000 years to complete. Apparently what happens is the Earth's magnetic field shrinks, does not disappear totally, but shrinks. It turns over, and it grows again the other way around. And then when it's time for the next flip, it shrinks, turns around, and grows again. And each of these shrinking, turning, and growing takes 5,000 years. At the moment, the Earth's magnetic field is shrinking. We've only been measuring the Earth's magnetic field for about 200 years, however. Gauss first did it. So we don't have a very good database. But it's shrinking at something like 5% per century. Of course, what we don't know is whether it normally meanders around a bit in strength, shrinks a bit, grows a bit, shrinks a bit, or whether this is the precursor of a reversal. We just can't tell. But whether it's a precursor of a reversal or not, given that this flip takes 5,000 years, it's not going to be happening by the 21st of December this year, 6 months away. We've also revised our understanding of how the Earth's magnetic field is related to the spin of the Earth, the spin of the Earth on its axis. When I was a kid, we were taught that there was a great big loop of molten iron that went around, and this is what was responsible for the Earth's magnetic field. I think that was before they knew about reversal. And you can see with that picture, if there is a reversal, then this great big loop of current has to go round the other way, and maybe you would imagine the Earth stopping spinning and starting to spin the other way. But we now, as I understand, believe that there's a small circular motion, and this is amplified by the rotation of the Earth. And so you just have to change a little loop, and the new form will be amplified by the rotation of the Earth. So whether or not there's a reversal imminent, we do not expect Earth to stop and then spin the other way. That's fiction, I believe. So it's not the sun, it's not the Earth's magnetic field. What about the other planets and things in the solar system? Could the planets pull us away from the sun? Could things bang into us, collide with the Earth? Let's look first at planets being aligned, and we'll need the lights down a little bit for this one, so as hopefully you can see a smiley face, a crescent moon, and Jupiter and Venus. And Venus and crescent moon in the western sky. It was beautiful, and in Britain we had some lovely weather for that. Where you get a group of solar system bodies like this in a small patch of sky, it's known as a conjunction or an alignment. And a small one like this won't have much effect. But just suppose we got all the planets and the sun and the moon lined up on the same side of the Earth. Could that disturb the Earth's orbit? Something like that. So I've got a diagram here that's not fully to scale, indeed not at all to scale, with the Earth down the bottom. This is looking down on it from above. Earth, Moon, Sun, Mercury, Venus, I've left Mercury out, it's too small to count. Venus, Mars, Jupiter, and Saturn. Mercury is a very small planet, and as closest to the Sun, it's not that near to us. So supposing you got some big alignment like this, could all those heavenly bodies pulling together disturb the orbit of the Earth? There's actually two questions we need to ask. Could their combined gravity pull us away? Or could there be tidal effects, basically the gradient of gravity? These are fairly easy things to calculate. The gravitational pull on the Earth, it's largely due to the sun, which is in the blue. The moon is in the brownish colour, and the effect of the planets is in green. And you can't see it because it's too small. The green sliver would be 1/200th of that brown sliver. So combined planets are not going to pull us away from the sun. But tidal effects more likely, and perhaps should be considered more seriously. So tidal effects on the Earth due to the sun, due to the moon, and the planets are shown in green. And the planets in this case make up 64 millionth of the brown, which is why you can't see them. And this makes sense. If you think of tides in the sea, they're largely governed by the moon, with the sun adding for the spring tides and the neap tides. So that makes sense. So the planets aren't going to pull the Earth away from the sun, and they aren't going to tear the Earth apart with tidal effects either. Besides which, we've been there before, just a few times in the history of the solar system. The most recent such alignments were May 2000, when there were 5 planets from the Sun, and February 1962, when there were 5 planets, the Sun and the Moon. We don't remember those, do we? There wasn't an obvious effect. The next ones, September the 8th, 2040, 5 planets, Sun and Moon, no, sorry, 5 planets and Moon, 5 planets, Sun and Moon in March 2675. And note that 2012 is absent. There is no alignment of the planets in 2012. There never was going to be, there never will be. So what's all the fuss about an alignment of the planets causing the end of the world? Hooey. Okay, rather more serious. Impact. Some rogue body in the solar system collides with the Earth, and that could be serious. I'm going to talk a bit about planets called Nibiru and a bit about asteroids hitting the Earth. Starting with Nibiru. Nibiru is not a planet you learn about at school. It was apparently discovered by the ancient Sumerians, who flourished about 2500 BCE. They said it orbits the Sun every 3,600 years, and they said, or it is said they said, it's due to hit the Earth in December 2012. With just that amount of evidence, you can construct quite a lot of information about this planet Nibiru. And for the benefit of the astronomers and physicists in the audience, I'm taking a conservative picture. I'll explain what I mean in a moment. If the orbital period is 3,600 years, that means the total extent of the orbit is 470 times the Earth-Sun distance, 470 astronomical units. And if it's going to hit the Earth, let's say this distance of 1 astronomical unit, the Earth-Sun distance, let's say it hits the Earth when it's closest, at its closest approach to the Sun. That means we have a very, very long, thin orbit. This is an elliptical orbit, but it's actually far too fat the way I've drawn it. For those who are into ellipses, the eccentricity is 0.996. An eccentricity of 1 is a straight line, there and back. So it's a very, very thin ellipse. Now, I said this was a conservative assumption, and I need to go nearer one of these screens. I could, here's the Sun, I could have drawn the ellipse coming up like this, the object passing even closer to the Sun than the Earth, and then hitting the Earth as it begins to move out from the Sun. But that would give an even more extreme situation than the one I'm going to describe. So this is the conservative version. So it's a very, very thin ellipse. As seen from the Earth or the Sun, Nibiru goes almost sort of there and back, there and back, there and back. And nature has been a little bit unkind to the ancient Sumerians, because as seen from the Sun, all this is against the galactic center, a very crowded star field. You can see some of the brighter stars in this star field. There are millions of fainter ones. And one of these objects is Nibiru. The normal way you spot a planet is because it moves across a star field. But remember I said Nibiru was going there and back, there and back. So if it is that one, well, it's probably coming towards us, moving very, very, very slowly, so you don't see much change. But the ancient Sumerians somehow knew that that was the planet Nibiru. They say it has an orbital period of 3,600 years. The normal way you get an orbital period is to watch 2 complete orbits. 7,200 years. And this work started in 2,500 BC. Doesn't add up. There haven't been 2 complete orbits since the Sumerians spotted this. So they were very clever astronomers. A, to spot, I've forgotten which one it is, but never mind. That one is a planet, and that it has an orbital period of 3,600 years. But, maybe they're clever astronomers. If Nibiru is going to hit us on the 21st of December, it's about there now. It's about 2.8 times the Earth-Sun distance away, puts it at the same sort of distance as the asteroid belt. It was furthest away around about 200 AD. It was last back around here about 1588 BCE. Obviously didn't hit the Earth then, but there was probably a fairly close encounter. And there were civilizations around then in Mesopotamia, Babylonians, Hittites, I think, were finishing, Hebrews were sort of starting, and in China there was the Shang dynasty. And none of these noticed anything, made any record. Slightly curious. And when the ancient Sumerians first spotted it, it was away out here at 400 times the Earth-Sun distance, or 10 times the distance of Pluto. Okay, if the ancient Sumerians are going to see it, and they don't have telescopes because it hadn't been invented, how do they see something like that at that sort of distance? Planets don't produce their own light. They reflect sunlight. They're big, dusty mirrors. And if I go back a slide, so we've got a big dusty mirror out here, the ancient Sumerians hanging around here. The sunlight is way out here, it's pretty dilute by the time it gets here, gets reflected, and it's even more dilute by the time it gets back to the Earth. If the ancient Sumerians are going to see this without the aid of a telescope, then it's got to be a big dusty mirror. It's got to be about 150 times the size of the Sun, or have a mass of about 3 million times the mass of the Sun. They don't make planets like that. They don't even make stars like that. So it can't be a planet. But many stars in our galaxy occur in pairs. The Earth is a little bit unusual. It's a singleton. It doesn't apparently have a companion star. But people keep looking and wondering if they found the Sun's companion star. Could Nibiru be the Sun's companion star? The two things would go round each other. So that's a possibility. I think if it's going to be the Sun's companion star, it's got to be a very faint, small kind of star called a brown dwarf. And that would make sense because a brown dwarf at 10 times the distance of Pluto, 400 astronomical units, would look quite bright, a bit like how one of the planets or the brighter stars look to us in the night sky. So the ancient Sumerians could see it without a telescope. But that was at 400 astronomical units. Today, at 2.8 astronomical units, we have a small faint star, but jolly close. And it's... You've seen it? Nobody's seen it? Nobody's seen it? Ah. It doesn't add up. I don't think it's a star either. In fact, I think Nibiru is just a piece of fiction. It's fun, but it's fiction. It's unusual amongst all the effects I'm talking about tonight. It's the one that is pure fiction. Every other one contains a gem of good science, a seed of good science. And something scary and quasi-scientific has been built on that seed to make an alarming story. But with Nibiru, I think it's fiction the whole way through. Okay, Nibiru's not going to bang into us. Could something else? Asteroids are a considerable hazard, and it's something that we have learnt in fairly recent years could be a hazard. The asteroids are odd-shaped lumps, pieces, basically bits that failed to form a planet. Probably failed to form a planet because of the presence of Jupiter and Jupiter's gravity. But that's by the way. There's a clutter of probably about 1 million such objects in a band in the solar system, in a band between Mars and Jupiter. And in this cheerful diagram, I've simplified things quite a bit to try and show you what's happening. I have left out the inner planets, but we've got Sun, Earth, Mars, asteroid belt, and Jupiter. Now, normally the asteroids stay in the asteroid belt, but if a star passed rather close to our solar system, something like that, it could cause an asteroid to change its orbit, and it might come in like this, cross the orbit of Mars, cross the Earth's orbit, go around the Sun, back across the Earth's orbit, Mars' orbit, out to the asteroid belt, and it might continue doing this. Now, just because two orbits cross doesn't mean there's a crash. When I was a kid, my brother and I shared a train set. And one of the things we had in a train set was a crossover. And when we got really bored, we tried to engineer train crashes at the crossover. And, you know, to make two trains crash, they've both got to be there at the same time. If one goes through and then the other goes through, there's no crash. So similarly here, just because an asteroid orbit crosses the Earth's orbit doesn't automatically mean there'll be a crash. Both have got to be there at the same time, or there at the same time. There's two opportunities. But there is now a category of object called a near-Earth object, or a hazardous object. And that's basically what I'm talking about. There could be small asteroids coming in. As they hit the Earth's atmosphere, they heat up, same way as the space shuttle heats up, or indeed any satellite heats up as it comes into the atmosphere. And if they're small, they'll heat up sufficiently that they glow, they're bright, and they burn up. Actually, for those of you near the front, you can perhaps see that this is broken into a number of lumps. That's due to tidal effects. And each of these lumps will glow, and it will probably burn up before it gets the Earth's atmosphere, but you might get a lump of stuff going bonk. And lumps of stuff have been known to go through the roofs of people's cars and the roof of a house. And there was a rather amazing report, which I don't think I fully believe, from Germany a couple of weeks ago about how a pea-sized meteorite hit a 14-year-old lad on the hand, bounced off his hand and made a foot-wide crater on the floor. And it was traveling at 30,000 miles per hour. I think it's not quite correct science there, but, you know, these things do enter the Earth's atmosphere. Some of them get down to the Earth. It's tough if it's your car that's wrecked or your house roof that's wrecked, but it's not the end of the world. Slightly bigger ones can get through and make craters. This is Barringer crater, sometimes known as meteor crater, in Arizona. And it's about a mile across, a couple of kilometers across. And it's believed to have been caused by an object that was about 50 meters across, hitting. The craters always end up a good deal bigger than the object that's hitting. And it's very tough if you happen to live there, probably curtains, but it's not the end of the world. These things are supposed to happen about every 1,000 years, so it's surprising there aren't more craters around. But that's another issue. Certainly erosion causes a number of them to disappear. And of course, sea covers a lot of our Earth, and you don't get craters in sea. So, okay, that's unpleasant if you live there, but it's not the end of the world. This sketch map shows Mexico, the Caribbean, a bit of Cuba, the tip of Florida, and they have discovered a crater here, which I'm approximately outlining. It's big. They reckon it was caused by a body that was about 1 kilometer across, impacting. It happened probably about 65 million years ago, and some people will say, oh, that's what caused the extinction of the dinosaurs. And they may be right, but actually the extinction of the dinosaurs is disputed. This as being the cause of the extinction of the dinosaurs is disputed. Slightly different statement. Some people are saying there's a date discrepancy, quite a significant date discrepancy between the dating of this crater and the date when the dinosaurs died out. But perhaps we take it seriously and say this kind of thing could cause mass extinctions. And the way it would cause mass extinctions, not just the dinosaurs that were grazing there, is they kick a lot of dust up into the Earth's atmosphere. And the dust would cut out sunlight. There'd be failure of crops and lack of food. So that's probably how it would happen. They reckon these things happen every 50 to 100 million years, and that last one was 65 million years ago, so we're about due for another one. So this is something worth taking seriously. And the astronomical community now does take it seriously. There are lots and lots of little, smallish telescopes. I mean, not little in this sense, but, you know, little in that sense. Smallish telescopes surveying the sky night after night after night. They're doing two things. They're looking for transient objects, things that go bump in the night, things that flare up and die away. Because up till now, we've done very little looking for those kinds of things. And they will also, in the course of looking for these things, spot anything that moves. And there is now a huge program to monitor the sky regularly for anything that looks to be bigger than 200 meters and looks to be coming within 4.5 million miles of the Earth. That's about 20 times the moon's distance. And these things are monitored and their orbit determined more and more precisely to ask the question, will it hit the Earth or will it miss the Earth? If it's going to miss the Earth by a good margin, it gets dropped from the list. But at any one time, there's about 1,000 objects being watched. And they reckon that if anything were going to come and hit us, we would get anything serious, we'd get several years' warning. We know of one object called 1950 DA, because it was last around in 1950, due back in 2880. At this stage, we don't know of anything else that is big enough and liable to hit us, that'll give us problems. But we keep watching. And given 2 or 3 years' notice, there are ways, even with present technology, that we could divert an incoming asteroid. It would be very expensive. It would require all the countries on Earth to collaborate, but we could do it. Some quite neat techniques. One is, for instance, you're on the Earth. I'm an asteroid coming in to hit you. Only there's no sound in space. What you do is you send up a rocket, not at me, but alongside me, and it carries a big tin of white paint. And you paint me white all over. The sun is that light up there. The sunlight bouncing off my glowing white thing exerts some pressure on me, and instead of coming straight at you, I go off to the side. You could do it equally with chalk, but just increase the albedo. There's something similar you can do planting a solar sail, which is like a great big sheet of cooking foil. Pressure from the solar radiation will move me sideways, and the net result is I miss the Earth. And there's other techniques that are being developed. So I think given a few years' warning, we can probably divert an asteroid. And we don't know of anything imminent, and we certainly don't know of anything due in December this year. So that's something we need to watch in general, but I don't think it's going to cause the end of the world this year. The final major topic is the Milky Way. There's a black hole at the center of the Milky Way, a big black hole, and we're going to fall into it. And that would be the end of the Earth. We can't see our galaxy very well because we're inside it. If we were outside it, it would look like this, which is the Andromeda Nebula. It's a thin disk. There's a black hole in the center. There's about 100,000 million stars. And the sun is not anywhere near the center. We're about 2/3 of the way out. We know there's a black hole at the center of our galaxy because of this, which we'll leave running for a minute or two. Each of these spots is a star seen in the infrared. It's a string of photographs put together to make a video. This is the date. Starts in 1995, runs to about 2010. If you watch this object, which actually starts, that one in particular. Choop. Wonderful demonstration of Kepler's laws. Things move in straight lines unless something keeps pulling at them to make them go round a curve. There's clearly something about here which is making that one go round in a curve, and that one, and that one, and that one, and that one. Indeed, physicists in the audience might like to watch, I think it's this one. Forgotten which it is. There's one going in a straight line. Yep, going up here, this one. Everything else is curved. That one's in a straight line, which is interesting. There is something with a lot of gravity here. It's a black hole. We can't see it, but it's got a mass of about 3 or 4 million times the mass of the sun. And it's a lovely little video, but we ought to push on. So, here's the Andromeda galaxy serving as a proxy for our galaxy. There's the black hole in the center. The sun is out here about 2/3 of the way out from the center, and the Earth is doing an orbit round like this. The Earth's orbit is not in the plane of the Milky Way. It comes out at an angle of about 60 degrees. This is hugely not to scale. But in December each year, in particular on the 21st of December each year, Earth, Sun, and black hole are in a line. So this is what's given rise to the idea that the Earth and the Sun, and presumably the other planets, are going to fall into the black hole on the 21st of December. It happens every 21st of December, so why this 21st of December is not clear. Added to which we're traveling around the galaxy at a fantastic speed, 220 kilometers per second. That will keep us out of the black hole. The gravity from the sun is 100,000 million times the gravity from the black hole, so that doesn't quite stack. And even if we did get the sun and the Earth going towards that black hole at the speed of light, it would take us 26,000 years to get there. So we'd be late for that appointment in December the 21st this year. So never waste a good crisis, as they say in management circles. You can buy T-shirts and bags and mugs. You can buy personal survival gear, gas masks, water purification tablets, food storage and survival handbook. And I'm interested to note that a number of the survival things come with a 180-day money back, if not satisfied guarantee. More seriously, what is going on? There's a lot of misinformation being put about. Why? Why do people fall for it? Who's doing it? And can we do anything about it? There's the disaster movie, 2012, and I used to think that it was that disaster movie that was driving this. In fact, I think it's climbing on the bandwagon. I don't think it's driving it. But what is very interesting is this website. IHC stands for Institute for Human Continuity. It looks like a professional academic. Well, no, it doesn't look like an academic website. It's too good. It's very slick. Preparing the world for 2012. Interviews with experts saying how the world's going to end. Odd references to the 2012 movie experience. And if you could read the small print down here, it would say Sony Ericsson. It's put up by the film company. It's a viral marketing website, and it's sinister. It's horrible. I love this website, manyendings.com. The front page is a list of dates, and you click on your favorite date, your favorite year. I chose 1954, and up come the 1954 predictions for the end of the world, or the predictions that the world would end in 1954. In Rome, the Colosseum started showing cracks. The book of Revelations talks about cracks in the Colosseum. So everybody rushed to the Vatican for a blessing. Didn't happen. This is a particularly interesting one. This is a group that predicted the Earth would end by flood on 21st of December, 1954. A sociologist by the name of, he's in here, Leon Festiger, decided to investigate this group and planted some of his research assistants as acolytes. And they observed what happened. So come midnight on the 21st of December, they're sitting in this front room somewhere. And nothing happens. Oh. The clock in here is fast. The one in the lobby is correct. So they sit another 5 minutes. Nothing happens. They sit and they sit. And finally, about 2 o'clock, 3 o'clock in the morning, the leader of the group gets a message from God. Because of the faithfulness of this small group, God has decided. What is certainly counterintuitive, and I find very disturbing, is Festinger shows that if people believe the world's going to end for a certain reason, and it doesn't, they believe more strongly they were right. So we're not in the land of the rational. As I've already said, in many cases, there's a sound piece of science behind this, and somebody with a fair amount of scientific knowledge has taken that and built and twisted and produced something that scares people. And apparently many of us don't know enough science to know when we're being told something stupid. What is interesting is that certainly in Britain we have had similar scares over other things. And if we could work out how to deal with this one, we might be close to working out how to deal with those ones as well. So there have been scares about HIV and AIDS. We've had scares about vaccination, suggesting that the measles and whooping cough vaccination causes autism in small children. Maybe it was measles vaccination. They're all combined in Britain. There's a certain amount of misinformation being put about climate change, and that's very noticeable in the United States as well. And some of these things cost lives. This astronomical one doesn't in any big way, although you may remember that when Comet Hale-Bopp came along, There was a group that said, aha, there's a satellite following in the wake of Comet Hale-Bopp, and it's coming to take us away to a better place. The snag was, in order to join that satellite, you have to leave everything earthly behind, including your body. So there were some mass suicides just before when they reckoned that satellite was going to land. There wasn't a satellite in the tail of Comet Hale-Bopp. It was a star that we're seeing through the tail of Comet Hale-Bopp. And it's particularly hard to put a lid on these things, because if somebody like I go around saying, what I've said, there'll be people who say, well, you would say that, wouldn't you? The government knows trouble's coming. NASA knows the trouble's coming, and they're hiding it. And you professional astronomers clearly are in league with them. So the more you try to put a lid on it, the more you play into conspiracy theories. And I don't really know how to deal with that one. What's been quite an eye-opener for me is to realize that rational arguments don't always do the trick, because we aren't totally rational people. I'm not saying it's irrational, it might be, but it's certainly irrational. So there are places that rational argument won't reach. One of the things we've got to get sussed out fairly soon is how to help people distinguish between sensible websites and bonkers websites. And there are a lot of really mad websites about the end of the world in 2012. And with experience we learn how to discriminate, but how do you teach that to other people? And yet we've really got to start doing it very, very soon. And how do we create a society that's mathematically and scientifically literate enough that it can distinguish between stupid science and sound science? Thank you for your interest. Thank you very much. Thank you very much.
Thank you very much, Dr. Burnell. On behalf of the 2012 GA Committee and Edmonton Centre, we would like to, as well as the National Office, we would like to present you with this little token of our appreciation.
Thank you. That's very pretty. Thank you very much. Can I open it? I've been told to open it. This will take time. You better go on, Howard. It's a shame. It's beautifully wrapped. But it's a box. A black box. Oh, it's a pendant. It's a bit of white quartz meteorite pendant. I won't pull it out too hard. Isn't that beautiful? Thank you so much. That's really special. Thank you.
You're quite welcome.
Thank you very much.
We are on. This is the Helen Sawyer Hogg Prize Lecture, and it is my pleasure, and again my honor, to present you with a certificate.
Ah.
Framed, we'll ship it, so we'll leave some of the wrappings on. But we're delighted to present you with this, and right behind here is a little honorarium.
Oh, lovely. Thank you so much.
The important piece of paper.
That's very fine. Thank you very much.
Thank you very much. We've just been delighted here tonight, haven't we?
Thank you. That would be great. Yeah, and we'll ship it, so you let us know where you want it.
Thank you very much.
Okay, folks, we'll now open the floor to questions. We only have the 2 roving mics, though, so I won't be saying anything. So if you have a question for Dr. Burnell, if you could just raise your hand, and I'll guide our mic bearers to their respective locations. Okay. Saw a hand up there somewhere. Yeah, white shirt top.
I was just wondering, in recognition of what happened with your discovery in the 60s, do you feel that there has been some changes to how researchers are achieving recognition and getting fair credit for their discoveries?
I think things are undoubtedly changing. The image we used to have of the way science was done was that there'd be a senior man. It nearly always was a man, probably in a white coat, but that's incidental. And working under this man, there'd be maybe quite a large group of people. And they weren't expected to think. They were just expected to do what he told them to do. And so he got the credit for any success. He got the can if there was any trouble. But I believe the way we do science these days is much more as a group or as a team, mostly. There are still some people who work on their own, but most work is done in groups or teams. And sure, there will be the principal investigator who's got the money, but people will be making suggestions and taking on tasks. And hopefully you have in your team a fairly diverse group, so you've got all bases covered that way. And I do believe that's the way science is done now, which makes it very difficult for the people who award prizes. And I've been on some prize committees, so I know. Prizes can normally only be awarded to a limited number of people. And, if you've got a team of 10 people, what's the prize giver supposed to do? So in one sense, prizes are now an anachronism. But, yeah, I think it's changed.
Yes. Is this okay? Can you hear me? Yeah. Okay. Closer? Okay. Good. Cool. I read an article recently about, and I wish I could remember where I'd read it. It was about people who were members of cults and doomsday cults and things like that, and who believed that the world was going to end.
I'm sorry. Can I stop you a second?
Yes.
I'm not hearing you properly.
Sorry.
Can you speak up a bit more?
Louder. Mike, stand up. Okay. Cool. I read an article about doomsday cults and the people who believe in them, and there were people interviewed, and everything from Harold Camping's followers to people who were selling all their possessions and then buying an underground bunker to survive.
Yeah.
And there was, almost as a footnote to the article, they interviewed one guy who used to believe in this stuff.
Yeah.
I think it was a guy who had followed Camping, but when the world did not end like Camping predicted, he stopped believing in it.
Yeah.
I have to wonder if anybody is studying this in detail, collecting interviews, collecting anecdotes, to figure out how people think before and how they think after once they've got out. Do they think more rationally? Or have they just had a rug pulled out from under them like Santa Claus? I don't know, but if we want to know how to stop people from thinking that way or how to get them to think rationally, maybe those are the people we need to be talking to.
I don't know the answer to what you're specifically asking, but I do know that a number of sects are being watched, and they have identified signs that indicate when a sect is becoming more serious or changing direction or maybe heading towards a mass suicide. And those indicators are looked out for, and if they think a group is, like Waco or somewhere like that, that's going to do a mass suicide, then the authorities now have some idea when's the appropriate time to intervene. In probably any group, there's probably always one or two doubters. Maybe they never were that convinced to begin with, and they think more rationally and they leave. But the majority normally stay, which is the scary thing. Yeah. Wait for the microphone. It's okay, microphone's coming to you.
Hi, you said we have 3 years before we can planning before an asteroid hits Earth. You said we can somehow save ourselves from it. How exactly do you deflect an asteroid like that?
Well, you try and push it sideways a bit. One of the techniques you can do is send up a rocket with a nuclear warhead. Do not send it directly at the asteroids like the Americans would like to do. Send it alongside and let off the nuclear warhead, and the explosive force will hopefully not disrupt the asteroid, but will drive it a bit sideways so that it goes a bit sideways and a bit towards the Earth and ends up doing this kind of thing. So techniques like that. The reason you don't send it directly at the asteroid is you'd break the asteroid into 1 million pieces, and you then have the trouble of tracking 1 million pieces, which is not clever.
Yes, I thought every few weeks or every few months we have a surprise asteroid coming between us and the moon. So I find that very interesting. And aside from that, it seems there are a number of topics, a number of ways in which the Earth or civilization or mankind could end in physics ways. Cosmic rays, supernova, and all these kind of things, which I can hear you talk about.
Yeah. A cosmic explosion like a supernova or probably a gamma ray burst, if it were too close, could be very serious. But it's estimated that it has to be within 25 light years to be really serious. And there's not much within 25 light years that's going to do a dramatic explosion like that. Betelgeuse is probably the nearest thing, and it's 7,500, something like that, light years away. And although it's fairly likely that Betelgeuse will go up sometime, I don't think it's going to be very soon, because usually there's all sorts of variability first. But yeah.
What about those asteroids that keep whizzing past between us and the moon?
There's been some small, certainly a small one. Was it last November? Something like that, which we knew about and we knew wasn't going to hit the Earth. It was interesting because it was fairly dark material, so it was quite hard to see. And it was a pain for amateur astronomers because it went, phew, you know, fantastically fast, past our ears, so to speak. But, yeah.
Ma'am, on the vein of the weirdness here, it seems like European countries like Denmark, Sweden are becoming more secular, and our neighbors to the south are going the opposite way. Do you have any explanation for that?
What I do know, which is true in Europe, and I strongly suspect is true this side of the Atlantic, is that religions that claim to have the answers are growing. And religions that try to be a bit more subtle and grown up are declining. Some people want answers. Nice black and white answers. It's this, and I get on with my life. That, I think, is the nearest I can come to it.
Yeah. Thank you.
Way up the top.
There's a bit of Canadian humor that you might not get, but it is said the world will end tonight at 7 o'clock, 7:30 in Newfoundland.
wouldn't be an interested party, would you?
Way at the top back there.
So we've got this incredible opportunity to listen to one of the legends of astronomy speak. And I just want to basically ask you, what do you tell to younger students, younger children, to get them interested in astronomy or science in general? And what suggestions do you have for our younger generations?
Oh, yep. It seems to be fairly easy until about, I don't know, 11 or 12 when puberty hits. They're full of questions, full of interest, and whatever you tell them, they'll be asking intelligent questions. And then when the hormones start, we start playing roles, don't we? And where the male and the female roles diverge, and it's not cool to be interested in anything. So that, I think, gets a really, really difficult phase. I actually think the most important thing we can teach young people is to think for themselves. Don't follow the crowd. Don't follow the herd. But there's very great pressure on us as young teenagers to conform to whatever our class norms are. So it's very hard. And I don't have a real answer to your question, Greg.
Orla, down here, lady in the green, and there's one, your next step.
And
okay, you.
Howard, Howard, there's one near the front of the aisle here.
Oh, there is? Whereabouts?
A Japanese lady.
Okay.
Sorry.
I'm very curious why you chose this topic for your talk tonight.
Right.
I'm sure there's a story behind it.
There's not a huge story behind it, but I got given an award by the Royal Society of London for the communication of science, and part of that was to do a lecture. And I was interested in this topic because of the way people are reacting and not being rational, and because also I suspect that some of the people perpetrating these scares have actually got science qualifications. So I started doing this lecture a little bit over a year ago. I have to say it's improved since the first one. But that's basically why I developed it, because I thought it would be appropriate as the prize lecture, given what the prize was for. It produced an enormous audience, some of whom went out saying, well, I don't care what she says, the ancient Mayans were right about everything else. I'm sure they're right about this.
Hi. Actually, leading from that, I was just wondering if you have advice for scientists on dissemination of some of the knowledge that they have?
It's an area where I think there's been huge change in recent years. Until maybe 10 years ago, dissemination of your research to the public, not proper. And there were no brownie points for doing it, and it didn't count towards your promotion or anything. And I'm not quite sure what turned the tide on that one, but it's now perceived to be much more important to talk to people about what you're finding in your research and what's going on. And it's a credit-worthy activity now, which is very, very interesting. However, there are clearly some scientists who should not be let anywhere near the public. So I think it's a mistake to say that every scientist should be doing it. You then run the risk of saying, well, the real scientists, of course, do the research, and other people do the dissemination. And we're seeing just a hint of this in Britain. There are few enough female science graduates as it is, a disproportionately large number of them are going into science communication. So we're in danger of getting a ghetto system. The men do the research and the women communicate it, which I don't like. The way we're going. Yeah.
One last silly question, if there weren't enough of them. If the world is not going to end on December 21st, when is it going to end?
When is it going to end? Well, the astronomical answer to that is fairly easy. In about 1 billion years, because in the course of its normal main sequence evolution, the sun is gradually getting a little bit hotter and hotter. And in about 1 billion years, it will boil the oceans. And that certainly, I think, would be the end of life on Earth, if not the planet Earth. The next interesting astronomical obstacle is probably in about 3 billion years, because it's suspected that the Andromeda Nebula and the Milky Way are going to collide. Galaxies are very empty things, and mostly it'll be things passing through, but there'll be tidal effects rather than direct hits. And the sun and the solar system could get, whisked out into one of those streams that you see coming out of galaxies like the antennae. I think actually myself, much greater danger is climate change, global change arising from climate change, and the kind of strife that there'll be at the very least, and if we're unlucky, the world becoming uninhabitable. So I think we need to watch our carbon footprints.
The lady in the gray. You, yeah, just her. You had your hand up, didn't you?
You? You still have a question? Somebody's asked it, okay. Oh.
I've been wondering about this really through the whole talk. Is there anything aside from a fleet of Klingon warbirds that we can't see in advance, can't predict, and would be completely and invariably fatal to everything on Earth?
Well, all-out nuclear war would be bad.
Okay.
But I'm not sure I can clearly predict that. Politicians yelling at each other, that's clearly very bad for the Earth, yes. We have a theme park in Britain that we call Westminster. Yeah, where
There has been a rise in religious fundamentalism in North America, and usually that's accompanied with abandonment of science or scientific principles in general. Do you have any insight of why that is? And does that mean that religious and science cannot live together, or is there a way where both worlds can actually live side by side, or is that desirable or not? I mean, what's the end game in that apparent debate?
Yeah. I am actually, as Mary Lou said in the introduction, an active member of the Quakers, the Religious Society of Friends. So I think science and religion can go together okay. But I also accept your point that many of these curious groups are at least quasi-religious, and sometimes in a very, very funny way. I personally don't follow all your argument, having agreed that some of these curious groups are curiously, religiously as well. It doesn't automatically follow that therefore science and religion can't fit together. I mean, I don't follow the chain of I don't agree with the chain of your argument. The snag is there's a hell of a lot under the heading of religion. Some of it crazy, some of it brilliant. There is actually also a hell of a lot under the heading of science. Some of it, to do with bending spoons, and some of it brilliant. So we just have to be a little bit careful, I think, to be clear about what we're talking about when we use those umbrella titles. Is that fair, do you think? He says reluctantly.
I was pleased to be in Tikal in Guatemala and Belize last November, and was able to go on some of the trips up into the Mayan ruins. And I thought I'd just like to tell you that the people that were doing the tour, the guiding, were very much happy that the Mayan problem was occurring, because lots of people were coming in order to do lots of tourism. But on the other hand, they were very willing to say that, you know, the long count, the 26,000-year cycle, that it was just, again, a new beginning for another 26,000 cycle. And that, in fact, in their view, nothing was coming to an end. It was just a new beginning.
Thank you for that. That's what I had heard, but it's good to have first-hand evidence. Thank you.
There was somebody, there we are, yeah. Okay. Well, we have room for, we have time for about maybe one or two more questions at the most. So, go ahead.
Yes, I read some very interesting psychological research, and it talked about how to debunk beliefs that are implanted in people's brains. And one of the things that it said, now I'm wondering if you would agree with it, is that in order to displace a faulty notion, you must replace it with an equally valid explanation. And I think in the case of 2012, and it's something that annoys me greatly, because I have a young son, and kids that are 7 and 8 year olds actually get quite nervous about this. They actually get physically and mentally disturbed because they can't recognize the difference between something that's bunkum and not. And I think, you know, part of my explanation is there are odious people in the world who are trying to make money and trying to increase their influence over people, and that's why this is happening. And are we saying that, would you agree, and are we saying that clearly enough to people?
I agree with your assessment. I think you're spot on there. If you go on the web and Google something like End of the World in 2012, you get thousands of websites. And, you know, about a dozen of them are astronomers trying to imbue some sense. You can usually identify them because they're either coming from a professional body or they have an academic address. That's where you find most astronomers. But it does very much concern me that I think particularly young people need help in discerning what's a sensible website, what's a crazy website, and need to be given guidance like, you know, well, reliable websites are probably the ones produced by the professional bodies, and the ones that end .edu, and the ones that, you know, .ac.uk and that kind of thing. So I think there are things like that we could do, encourage people towards certain websites. But there is all sorts of wild stuff there, which is very disturbing. And there aren't that many of us engaged in debunking 2012. I think there are probably actually very few of us doing it very publicly, because I know if you Google it, you find this woman talking, and not many others. So maybe we're not doing enough about it, and we've left it a bit late.
Make the gentleman with the blue shirt here. Yes, the one that just turned around. Yeah, you. Make you the last person.
Okay. Right, wait. Thank you. Okay. I think we all have this in our minds. You are a delightful and inspiring speaker, and we really appreciate you giving this extra time to answer questions that go from social psychology to when the Earth will end and that sort of thing. I just would hate for you to leave us without leaving us a story from your own life, from your personal career, from your career in research. And I wonder if you could pick a time, a moment in your obviously very interesting research history just share a little gem from your own memories.
Thank you. Okay, I'll try and make it brief. There's been allusion in reference in the conference today to Alouette, Canadian satellite. I worked with Alouette data. I think it was Alouette 2. Was there an Alouette 2? Yep. For a short while, I worked on what's called topside ionosphere. There's this layer of partially ionized material we call the ionosphere. And this Alouette satellite was probing the top side of, from above, of the ionosphere. And the way it works with a satellite is you get a subset of the data initially. It's called quick look, so as you can see if everything's working properly. And then the people responsible for the satellite and the data pipeline do the calibration and the cleaning and pass you the final data. And in the quick look data, there was a very interesting sharp change in the topside electron density. It's known as the mid-latitude. Gosh, I've even lost the jargon. Anyway, there's a sharp trough. And I started a research project to see what sort of latitude, longitude this trough was at, depending on, for example, how active was the sun. And it was very interesting, waited with bated breath for the full data to come. The people responsible for calibrating and cleaning the data told the girls, and it was girls who were cleaning the data, to take out any sharp spikes or troughs. You've guessed what happened. They took out our nice, sharp, mid-latitude trough. We had no data. Beware of cleaning data. Beware of over-cleaning data. Yeah.
I'd like to thank Dr. Burnell once again and remind everybody in the audience that we do have a reception outside, just outside the doors here, and it'll be open for probably a good 30 or 40 minutes. Thank you very much for coming, and I hope you enjoyed the evening.